We've looked at how to organize data, we've looked at how to present data, and we've looked at how to use descriptive statistics to describe a population as far as what its center is and how spread out it is. What we're going to look at now is how to tell where an individual is in this population. Where do you fit in? Are you at the top? Are you at the bottom? Are you somewhere in the middle? So let me give you an example. American males' heights are normally distributed. We'll talk about that. It basically means nice and symmetric, with an average, a measure of center, at about 5'8" and a standard deviation of about 4 inches. So I'm 5'10". Where does that put me? A little bit above average, but not by all that much. That's not a good enough answer for statistics or math. We need to attach a number to something. So we're going to look at a couple different ways to describe that. One is called the z-score. We're going to do that next time. But this time we're going to look at the percentile score. And the percentile score is very simple. It's just the point where a certain percentage falls below you in the distribution. So if you're at the 50th percentile, you're right in the middle. 50% falls below you, 50% falls above. If you're up here at the 90th percentile, 90% falls below you and 10% falls above. If in the example of heights of males, we're talking about the National Basketball Association, they're going to be way up here at the 99th percentile because 99% of the population is shorter than them and a very small percentage is going to be taller. Right? So it's just the percent that fall below you. Let's take a look at our made-up set of data here. We've got 16 numbers. N is 16 and always represents how many things there are in our population or in our sample. And to calculate the percentile, all we have to do is look at how many fall below the one we're looking at and what percentage of the population is that. So here we're going to divide how many fall below you divided by how many there are in the sample. So looking at 13, I want to know 13's percentile score. Well, 13 looks to be towards the low end of the data, so it's going to be less than 50th percentile, but it's not going to be all that small because it's not really close to the end. So how many fall below 13? 1, 2, 3, 4, 5, 6. 6 divided by 13, and that, I'm sorry, not by 13, by how many things there are, by 16. So 6 divided by 16 is going to be, that's 37.5. So going to be at about the 37th percentile. That's the way we say it. We abbreviate it PCTL. We say that 13 is at the 37th percentile, which just means 37% of the population falls below 13. For 377, that guy's way up here, almost at the top. So the number is going to be closer to 100% than it is going to be to something like 37%. But if we count, there are 16 total things. There's 3 here, which means that 13 fall below 377. We have 13 divided by 16, and that is going to give us, refer back to the calculator over here, 13 divided by 16 is 81.25. So that's 0.8125, so at about the 81st percentile. Now I'm not going to get real picky about rounding things correctly here because the percentile score just gives us a sense of where something is in the data. So if you were to round this to 38th percentile, I don't care. I still know that we're in the bottom half of the data, but fairly close to the middle because 37 is not all that far from 50. Here I know 81st percentile, that's around the top 20%. If you had rounded that to 82nd percentile, I wouldn't care. I want you to be able to tell me, for any member of the population, what their percentile score is. That tells you about where they are in the population. But also, I want you to be able to find the cutoff point for a particular percentile. So suppose I want the cutoff for the top 20% of this data. That's the, 60. If I want the 60th percentile, that's going to be the cutoff for the bottom 60% and the top 40%, right? 60% are below. So 60th percentile, I know that's going to be somewhere, not in the middle, but somewhere to the right of the middle. multiply 0.60 times 16, right? 60% of 16 is going to be 0.6 times 16. That's 9.6. So the 60th percentile is where 9.6 of these data points fall below. So just count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9.6 would be right there between 34 and 55. So that's going to be our cutoff point for the bottom 60% and the top 40%. So I'm going to say that 34 is at the 60th percentile. It's greater than 60%, less than 40%. If you were to give me 55 instead of 34, I'm not going to complain about that. You still have an idea that that is the cutoff between the 60th percent and the top 40%. How about the 30th percentile? 30th percentile is going to be down here because we want where only 30% fall below. So 0.30 times 16, and that's going to give me 4.8. So I would count up 1, 2, 3, 4, and draw my cutoff point right there. So I would say that 3 is at the 30th percentile. I would also accept if you said 5 was at the 30th percentile. Okay, and that's percentiles. I expect you to tell me what percentile is this score at, and also find a particular percentile. See you next time. We'll talk about z-scores.